Hello everyone, welcome to the lecture on cloud computing development. I think this might be a short one, but let's see how it goes. In the previous lecture, we covered the concepts of service-oriented architectures and web services. We discussed a set of definitions, and our discussion went into looking at WSDL and UDDI. With regard to SOA or service-oriented architectures, you are aware that they are autonomous and stateless business functions. They accept requests and return responses, we know that, and they use well-defined standard interfaces and standard communication protocols. So it's about making it simple, right? So in that context, we also looked into what a service means in terms of cloud-based applications. And what we know about a service is that it operates on the basis of a request and response model, as we said before. In other words, a client requests something and a server responds. We have also emphasized a lot on the need for developers to move away from monolithic approaches to software engineering. And that's exactly what SOA and web services help us with. So in order for us to go away, or rather move away from monolithic deployments, we need to start making use of components which are made available on the cloud, and SOA and web services help us do that. We looked into the flow of operations between the client and the service provider and how each service provider needs to publish a list of services offered with the registry. And as we know, the registry is discoverable. So if you're a developer and you want to use some of the services, you will have to discover the services first from the registry, and then you can readily use it. And then our discussion last week moved on to web services, and there's actually quite few definitions of web services we considered, and one of them was where we said web service is a URL addressable software. It's a software resource that performs functions. It's a URL addressable software resource that performs functions. What that means is that any web service can be accessed via an URI. One of the main messages I think we derived from last week's lecture is that web services need a simplistic approach for access and to perform operations. So in that context, XML was discussed. Yeah, so do you remember about XML? So we discussed about XML as well, and how we said it should be simple, so therefore XML is simple, and it allows for easy communication between the service provider and the user. So in this lecture, we will look at SOAP and RESTful web services. SOAP, S-O-A-P, stands for Simple Object Access Protocol. It's an open XML based format. Like always, like before, we emphasize upon the simplicity of this using XML. So it's an XML based format for sending messages. We will also discuss things around representational state transfer, or RESTful. It's called representational state transfer, and it's an architecture, it's a software architecture consisting of guidelines and best practices for creating scalable web services, right? We will also look at the structure of SOAP and RESTful web services and how they are structured using XML. So guys, again, this module is not going to teach you XML. I'll just make that very clear. I made that clear before. I made that clear in the last week's lecture, but it's not about teaching you XML. You should know this already, or you should have some software engineering background, which makes it understanding XML a lot more easier. So we are not going to teach about XML, as it's not a part of the learning outcomes, but no, you are strongly encouraged to look at how XML is used within SOAP and web services framework. All right, so please do look into how XML fits into all of this. And like I said, I will not go into detail explaining each line of XML script, right? That's not the objective of this module. This is something, learning about XML is something you have to do yourself as a part of your learning. There are some example XML scripts later, which, for example, to show the request and response. But it's entirely your responsibility to do further research and fully understand how these work. All right. So if you don't know how XML is, it's pretty straightforward to understand. XML is pretty, as I told you again, it's very simplistic. So it's very easy to understand. So please have a look, see if you're able to understand the XML scripts, which will follow in a few slides. So this week's lecture agenda is getting the theoretical overview of what SOAP is and what is RESTful web services. And also we also look at the format of web services. We look at how these are structured. So yeah, like I said before, this might be a very short lecture, but let's see how it goes. In the previous lecture, we discussed some of the terms mentioned on the slide. So you see that terms that loose coupling, abstraction, reusability, etc., etc. We discussed how web services can be delivered over the web using a URI. We looked into how a software developer can readily make use of these tasks, and he can simply do so by sending a request over the web. And this is what we may mean by discoverability. So all the services are provided by a cloud provider are exposed to a developer who wants to develop an application, and the developer can access, or an application can access, these services readily by just merely sending a request over the web. All right. And we all know that each of these web services are autonomous, which means that they do not depend on other services. They're standalone, really. So yeah, they're pretty much standalone. And yeah, from that point onwards, so what we will do after that discussion is we'll apply that to SOAP, which is Simple Object Access Protocol. So that's what we'll be covering in this week's this set of lectures. So I have mentioned previously about some standards or protocols required to enable access to web services, and you should remember this. So yeah, I did mention a set of standards or protocols to enable the web services, and I also very specifically remember telling you that the simplicity of XML makes it an ideal choice to be used in a protocol for communications, right? And that's exactly what SOAP does. SOAP, as you guessed, uses XML, and it's a format for sending messages. It is defined in W3C, and it's open standard. So let's look at what a SOAP message actually consists, right? It's all about how we're understanding the structure of a SOAP message. So it contains a SOAP header, a SOAP body. The SOAP header is used to declare, or rather describe, the parameters to be used within the message. All right. So to say that, I'll repeat that again. So a header, the SOAP header, is used to declare, or rather describe, the parameters to be used within the message. And the SOAP body contains the message data, and this could be either request or response. Please recall from the previous lecture that I mentioned that all of this is web-based communications, right? So it's a web-based communications between the client and a web server or web service, and therefore they have to rely on standard protocols because it's all over. It's over the web. They have to rely on standard protocols. And if you look at the TCP/IP stack, what comes to mind in terms of standard web traffic? So you can probably guess. You probably have guessed that in the application layer, you have the HTTP, Hypertext Transfer Protocol, which is typically used for SOAP messages. Well, the web traffic, of course, but in context, because we're trying to keep things simple, SOAP can also use HTTP, right? Optionally, SOAP can also use TCP and SMTP as well. I hope that makes sense. Sorry, excuse me. So guys, there you have it. So yeah, if you look at the diagram there, imagine it like an envelope, right? Imagine it like an envelope which contains a header and a body. So think about it like you are using an envelope to write a letter to someone. You will obviously include the header, for example, the address, etc., etc. And then within the body, you have other details. So let's use a similar context here to describe how SOAP messages work. The envelope is the top level of the whole structure, and everything else comes inside the envelope, right? So inside you have the header, which is general information. So if you look at the SOAP envelope, you have, excuse me, you have the body and the header, right? So please remember that within the header and the body, the elements are application specific, right? So don't forget that between point A on a network, between point A and a point B over the web, there will be multiple hops that this message will have to transit. The information within the header can be processed and changed by intermediaries and or the recipient. However, what's in the body is meant to be consumed. Remember this. What's in the body is meant to be consumed only by the recipient, and the recipient only, no one else. All right. So the bottom line, header details can be changed in transit by intermediate devices, intermediate hops, but the body of the message is meant only for the recipient and recipient only. As a part of your learning, I would also like you to look up at some resources and learn the SOAP format in some greater detail. All right. I will put up a link for this on the VLE a bit later on. All right. So but if you just have a search around, you'll find a lot of resources online which goes into a lot more detail into how SOAP is structured. They will explain in detail how the header and the body is structured. So please make some notes on that one. So this is a SOAP request example. So unlike the last time, I would like you. I mentioned last time, that if you're seeing a script like this, I would like you to go a bit more deeper and make some notes on what these things mean. So again, I would reiterate the same message now. I would like you to make some notes on the tags you see in there. For example, you can see a tag called envelope, and we have XMLNS, right? So please make some notes on that. So I want you to think about how all of this fits in with the request and response model, right? It's all about someone requesting something from a web service, and that's a response. So I want you to think about how this script, so this is a request script, would apply in the case of a SOAP message request, right? Yeah. So again, I'm not sure how many of you have got experience in working with XML. But if you look at this, so for example, I think if you look at the sixth line there, yeah, there is a thing called XMLNS, which is the namespace, right? So it's the namespace. XMLNS is a namespace, and it tells to what namespace these definitions relate to, right? So all of these definitions, so for example, anything you declare, anything used from that point forward has to be related to a namespace, right? um, so I'll just give you a simple example. Let's say that both you and I write a simple XML script with similar elements. For example, I use an element called user ID, and you too decide to use an element called user ID. Now the question is, how do you tell them apart? How do you distinguish between your user ID, which you use, that element which you use in your script? How is that different from the user ID element which I define in my script? How do you distinguish? How do you tell them apart? And this is where the namespace comes into effect, right? So then with the namespace, we tell in which domain or context these elements are valid under. It also tells where the data types are coming from. All right. So within that namespace, the namespace defines the data types as well. All right. So this helps us alleviate any confusion and overlap of namespaces. All right. So yeah, please make some notes on this. This is something which you so this process of understanding scripts and making some notes on and understanding how all of this works is a part of your learning process. You'll have to incorporate that into your extra study. So please make sure you do that. And of course, we are here to help you. So if you're struggling with something, please let us know. So what you've seen now is a sample script of a sample XML file of a SOAP request, right? And in response to this, what you get is a SOAP response. You get a SOAP response. So that's a SOAP response. So again, you can see familiar elements, like you can see the SOAP body. You've got the SOAP header and the SOAP body. It's doing something as a part of the response. Yeah, once again, I would like you to explore this further and make notes on the relationship between the request and the response. It's pretty straightforward to understand if you've got some prior experience in programming with XML. But of course, if you've got any questions, please let us know. All right, I'm not going to go through every single line of what's given on that, because that's not the point of the module, right? I'll let you study that. So now, chaps, we'll go into RESTful web services. We touched upon this in the last lecture, I think. Yes, we did. So what is it? What is RESTful web services? It is a lightweight and scalable service that is based on the representational state transfer architecture. So that's an architecture called representational state transfer architecture. What it does is that it exposes some APIs, some application programming interface, from your application to calling clients. So let's say that you've created some APIs which has to be exposed to the outside world or to your clients. You would want to make sure that those APIs are made available to your users, right? So how do we make this possible? So representational state transfer architecture is one of the ways we can do that. It is secure, and as you know, it is stateless. So once the APIs are available to the users, right, a client can then access those APIs and perform predefined operations using the service. All right, so we'll go into a bit more detail into that. So representational state transfer, or REST, we call it as REST, works on the basis of every resource being associated with a unique URL. That's a standard thing. Every single resource which is made available to clients should be associated with a unique URI. All right. Because we are trying to make it, this goes back to the point I made earlier on. It's about trying to make things simple, right? On the web, everything should be simple. If a developer wants to use a set of functionality provided by a cloud provider, then it should be made available via simple access mechanisms, right? And that's what this does. right? So it's based on very simple operations which are typically associated with the application layer in the TCP/IP stack. And to be more specific, it's related to how HTTP works. So what RESTful does is it tries to map some of the functions to very closely to how HTTP works, right? So if you worked with HTTP, if you've gone into details of how HTTP works, it contains methods such as get, post, etc., etc. So there is a correspondence between how REST works and how HTTP works, because it can be done over HTTP. All right. So within REST, we see that each resource supports standard operations, or what we call a CRUD, which is create, read, update, and delete. And if you think about it, guys, it makes perfect sense, right? It makes sense for RESTful services, representational state transfer, to communicate and manage the operation using these simple methods. All right. So I know it's still not clear. So, but there are a couple of slides after this which will explain how simple really these things are. All right. So we'll put this into context in the next couple of slides. So how does this all work? So let's try to go a bit more deeper into this. How does REST work? Let's say a client wants to access a service being made available by a service provider. All right. So let's say, I'll repeat that again. Let's say a client wants to access a service being made available by a service provider. Obviously, there has to be some interaction between the client and the service, or the client and the service provider. And obviously, again, this requires request and response between the two parties. So this request and response could be based on a native HTTP request, right? So you've got to remember that it could be based on a native HTTP request. And I mean, it makes sense, doesn't it? I mean, HTTP has been like, the de facto standard, I suppose, for web communications. It's been there for many years, something which has been widely accepted as the protocol to be used for web traffic. And also it's so simple to use, and it's something everyone is familiar with. So it makes perfect sense to enable these communications over HTTP. The advantage of using representational state transfer is that it's lightweight and easy to build, but it suffers from not having a common standard, and that is something in the pipeline. REST is the most common web service design. So I did tell you, I have told you that we will see some examples. So what operations can we do with REST APIs? So those are the operations there. So simple CRUD operations, or similar to CRUD operations. So let's actually see how simple this is. There are a few examples on your screen on how the standard get, post, and delete messages can be used. Okay, the things which you are already familiar. If you know how HTTP works, you know that's how it is. And these can be used with REST APIs. The first example says how you can use a get method along with the URL to access all the entries. Of course, there are more examples later on. Then there's a post operation which lets you create a new entry within the list of APIs, or you could be very specific and access a very specific entry using the API's ID. And that's a third example. And I'll let you figure out what put and deletes will do. So if you look at the second grid there, second line, I suppose, the second example, please note that the post body, in the post body, we have a JSON string. Do you see that? So we have the post body should encapsulate some sort of a JSON string. Now, for those of you who don't know what JSON is, it's a JavaScript object notation, and it's a syntax for storing and exchanging data And JSON is essentially text. It's essentially text written with JavaScript, and it allows us to store JavaScript objects in text format. All right. So again, that might be a part of your research. So no, so we don't teach you JSON. So if you want to look a bit more on how JSON works, then feel free to do that. So just to continue from the previous slide, these are some examples. As you can see, each resource which is accessible remotely is identified by a unique URL or a URI. Yeah, do you see that? Some are like in a collection, yes, but then you also have the ID there as well. Yeah, you can also access a single resource or a set of resources. It depends on what you want. It all depends on what goes in the get method. So if you want to get access to all the resources under, say, books, you can use the first example there. And if you want to access a specific resource with an ID, say ID 3, then you've got the second example, right? So similarly, post and put are straightforward to add new resource or to modify an existing one. Again, continuing with that, there are more examples here. So it all works on a similar basis. So I think the general message here is all you need is a URI. So URI basically tells you where the API is located. So remember, this is all accessed over the web. So the URI tells you where the API is located, right? So yeah, so you can delete a resource, update it, retrieve the source metadata, or inspect the source. Yeah, within those brackets, you can see that we have mentioned something about AJAX, which is well, it's beyond the scope of this this discussion. It's asynchronous. Yeah, it's asynchronous JavaScript and XML. So yeah, which is used to develop web services. Yeah, so Ajax is used to develop web services. So, but if you want to look more into that, obviously there's more. I've been telling you this, and there's lots to research upon. So there's not another thing to add to your list. So now we will look into what could be addressed via a web service. Think about it. So I just want you to, let's try to make it very simple. Let's try to just put things into context. So think about it. If you are a business, let's say that you are a business and you want to use a cloud service provider to provide automation to your business services. So this is the case, right? So the case I want you to think about is you are a business and you want to use a cloud service provider to provide automation to your business services. So what you would expect is a cloud provider would have some web services that will help you map your business operations into a workflow. So again, think about what does a business process comprise of. A business process has many stages. It's got many computational elements. It's got a flow. It's got a start. It's got an end. All sorts. So if you were to automate this using a cloud provider, you would expect your cloud provider to have some of these services ready made. It's some of these services readily accessible. So again, to be clear, I'm just trying to get this message across to you. Again, to be clear, every business has got a workflow, right? From start to finish, there are decisions to be made, operations to be conducted, and these could be extremely complex and time consuming if you, as a developer, were to do it from scratch. So what's the easiest option? You think about it. What is the easiest option? The easiest option would be for the business to access a readily available set of web services that can be instantly used to manage business workflows. Does that make sense? So would that be easy? So let's say that someone provides you these services through a cloud platform. Why do you have to reinvent the wheel? Why can't we just use it readily? And that's what this is all about, right? So this is exactly what we'll be discussing now. So we'll look at what is called as WSBPEL, Web Services, right? BPEL. So it's a business process execution language, and it's a standard for automating business processes. Essentially, it's a programming language to define the flows within process automation, right? So if you are setting up a business, you need to get some automation in there. So for the starting point would be for you to map out or rather chart out or draw a flow chart of how your business functions work and trying to establish the relationship between each of the business process. And once you have that, you can then think about how you access those services from a cloud provider. All right. So once again, I think you mentioned the word simplicity for the last few weeks. So we will again use the same word here. So again, simplicity is a key here, right? And as you can imagine, BPEL, right, the business process execution language should be simple. And how do you make it simple? By using XML, right? It allows us to describe the dynamics. Think about it. It allows us to describe the dynamics of a business model and how it should be executed using access to web services. That's the whole point of BPEL. It lets you create the mapping. It lets you draw the flow chart. It lets you, identify the processes. Not just that, it also tells you how to access those services from a web service or a cloud provider, right? So within the flow for your business, a very important part is service orchestration. There is something called a service orchestration. What you can do with BPEL is that you can visualize your process and the branches and identify which web services you need and invoke them. So everything is a part of the orchestration. What should happen when? At what point should a particular service be invoked? How does this business process branch out? What decisions need to be taken? All of this can be automated. It's a beauty, right? So yeah, we will provide. I know it's still a bit abstract at the moment, but we will provide you an example in the coming slide to see how the business workflow actually looks like, and that will help you understand this better, right? So I won't go too much into this. This slide kind of shows the different standards for web services composition. You can do some extra reading around this if you're interested. Our immediate context is with regard to BPEL, and this is what we'll be covering in the next slide. So yes, we will go into a bit more deeper into this, into what exactly is in a BPEL. So with the business process execution language, like I said before, it's all about defining the business process. As we all know, the business process can be very complex and it's not straightforward. There are multiple decision points, multiple data sets, multiple branches, multiple cycles, etc., etc. It can be as complex as you want, right? So what BPEL does is it can define control flow patterns. It can define control flow patterns which describe the complexity within the workflow. It talks about the sequence, the parallel processing, multi-threading, synchronization, etc., etc. So all of that comes within the control flow patterns. Then there is also the data patterns. Obviously, your business will be using data or a data set or a set of data sets. So the data patterns, this aspect talks about which data set to use and the data set interaction between the process and the data. So all of that is defined in there as well. The workflow must also account for resource patterns. The third bullet point you see there is about resource patterns. So it must also account for the resource patterns which define how tasks are delegated and when the resources must be invoked. Yeah. So it defines how the tasks are delegated and when the resources must be invoked. And finally, any business process is likely to contain numerous triggers. It is likely to contain numerous triggers or exceptions, and these need to be handled. For example, work item failure, deadline expiry, resource unavailability, etc. etc. Now, once again, I would like to go back to explaining what all of this has to do with web services. Well, once you have a business process, so think about it. Once you have the business process model and define it with BPEL, it makes it easy. It makes it easy to access the web services that are most suited to your workflow. Of course, as you would expect, each process could be a lightweight entity, right? But the good thing about all of this is the business or the application developer doesn't really have to know about what happens behind the scenes, right? As long as they know how to access a web service and implement it in their business, they don't need to know what it really does behind the scenes. The only thing the business has to do is they need to clearly know how their business works and what web services are the most appropriate to be implemented within the automation pattern. All right. So then, yeah. So if you have worked with flowcharts, this is pretty much straightforward. So how do you design? The question is, how do you design a workflow? It's simple, really. And like I said before, if you have written flowcharts, it's pretty much the same. You have a few elements to work with. These are basic, advanced branching, yeah, and synchronization based activities, triggers, right? Activity based on states and operations like cancelled or rather forced completion, etc., etc. Right? So yeah, so these are all stages. So each stage leads to another stage, possibly. So let's see how all of this works. In the next slide, I'll give you an example. So there you have it. So in the example we have provided there, I know it's not that clear, is it? I mean, it's pixelated, but I think you can still make out what the flowchart is saying. So in the example we have provided, it describes the workflow within a purchase order process. You see that? At the top, it's purchase order process. So within the purchase order process, there are different stages. All these stages have been mapped or rather created or defined between the start and the stop. There are some decisions taken and there are some branches, and you can see some routines, you can see some functions, some processes, and these are in the rectangles or the curvy rectangles. So once you have this workflow defined, this can then translate into an XML script. Yeah. And from that point forward, what can we do? It can be sent over HTTP and the services can be accessed. Does it make sense? So what you have on the left is a workflow, the flow chart of your business process. What you have on the right is the corresponding XML notation, more or less, which is what is going to help you to access the web services. All right? So yeah, this is the final slide, and it shows the excuse me. It shows the stack of web services technologies. We have covered some of these, and some, of course, you would have studied by yourself as a part of your research. But as you can imagine, there are so many other technologies and ways of implementing web services. Um, and for those of you who are keen on exploring this idea further, keen on exploring this stack future further, you can look into how other protocols contribute to the overall picture, including things like, you can see on the right there, quality of service, um, QoS choreography, QoS conversations, orchestration. So you can look at the various systems or protocols used to enable those activities within the web service stack of technologies. So that concludes this lecture. If you've got any questions, please drop us a line or ask us in the online tutorials. Sorry, I've been coughing through this lecture. I do apologize. I'm still sniffling. But if anything is not clear, no, I'm not sure if I know I've struggled through doing the voiceover for this lecture because I'm not feeling too well. So, but anyway, um, if anything is not clear, please give us a shout, drop us a line, or ask us. Thank you so much.